Hello everybody, this is going to be a help video for the odds on the type 3 on exponents. So we are on page 15 of your Unit 8 workbook, 8.1, day 3, it's our third day of 8.1, working on this type 3 practice. Now remember, the goal of a type 3 is that by the time we get to one of these, you are working independent of help. And from what I saw in class today, many of us have a really nice, solid start on just about all of these questions. But just in case, I'm going to help out and go through the odd questions, and we will check answers with each other as we work, and hopefully answer any questions you have as well. Starting with number 1, I'm going to zoom in a little bit. We have 5 to the 4th times 5 to the 6th. My bases are the same. This is product of powers. So we're multiplying two powers. Rules say that when we're multiplying two powers, we're going to add the exponents. So 4 plus 6 is 10. So I get 5 to the 10th. The math behind why this works, 5 to the 4th literally means 1, 2, 3, 4. 4 5s. And then 5 to the 6th is literally 6 more. 1, 2, 3, 4, 5, 6. So if I actually add up how many are being multiplied, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 to the 4th times 5 to the 6th equals 5 to the 10th. We don't want to have to write out these 5s every time like that, or whatever's being multiplied. It takes too long, and it's not necessary, because from this model we can realize that we add the powers and we get what we need, 5 to the 10th. You're literally adding together how many 5s are being multiplied. In this case, 10 of them. Applying this concept to number 3, make this a little skinnier. I have 3 to the 7th times 3 to the 3rd times 3 to the 6th. An important conversation we've been having is don't touch the base. What I mean by that is 3 is going to stay. It doesn't become 9, it doesn't become 27. We keep 3 as our base. How many 3s are being multiplied? Well, we have 7 here, 3 more makes 10, 6 more makes 16 3s total. In the denominator, 3 to the 4th times 3 to the 5th, that's 3 to the 9th. From here, we subtract the powers, because literally, if I were to draw or write 16 of these, and then divided by 9, I don't want to write them all out, they're going to cancel. Some of them will cancel because anything divided by itself equals 1. So 3 divided by 3 is 1, 3 divided by 3 is 1, and that's going to keep happening, right? So if we ask ourselves how many times it will happen, I have 9 3s here in the denominator. 9 of these 3s will cancel with 9 of these ones. Well, if there were 16 to start with, 9 of them canceled, that leaves 7 left. So we have 3 to the 7th as our answer. Number 5, 4a to the 3rd times 3a to the 5th times a. First off, we need to realize that 4 and 3 do not have exponents, so we can actually multiply 4 times 3 and get 12. And then let's gather our a's together. I have 3 a's here, 5 more makes 8, 1 more makes 9. 12a to the 9th. That comes from 3 plus 5 plus 1. Adding the powers, we arrive at a to the 9th. Number 7. Again, 11, 2, and 9. These do not have exponents. This is not 11 squared and 2 to the 5th. 11 is just 11, 2 is just 2, and 9 is just 9. So we can multiply 11 times 2 times 9. Let's do 11 times 2 is 22, and then off to the side we'll do 22 times 9. 9 times 2 is 18, carry the 1. 9 times 2 is 18 plus 1 is 19, 198. So I have 198 out front, and then our variable here is h. I have 3 values where I have a base that's h. So here I have 12 h's. 3 more makes 15. 15 plus 14, 29. So 198 h to the 29th power. Again, 29 came from 12 plus 3 plus 14. Number 9, let's get into some division. So my first focus point is right here, 27 divided by 9. I know that 9 goes into itself once and into 27 3 times. Another way of thinking of that is that 27 divided by 9 is 3. Now let's talk about the m's. There's 11 of them in the numerator and 4 of them in the denominator. So 4 of these m's, all 4 of these m's, will cancel with 4 of the 11. How many are left? 4 canceled out of 11. 11 minus 4 is 7. So I have 3 m to the 7th. You could choose to say divided by 1 or just leave that piece out, because dividing by 1 we would arrive at our numerator. So again, just to emphasize, we did 27 divided by 9 and got 3 first. That's where this 3 comes from. And then we did m to the 11th divided by m to the 4th. Quotient property, we subtract the powers, or we can reason, use logic, how many cancel and what's left and where, to get m to the 7th. Number 11. 4/16 is our fraction. 4 goes into itself 1 time and into 16 4 times. So we can see that as 4/16 reduces to 1/4. I've got 18 t's up top and 15 in the bottom. So 18 t's in the numerator, 15 t's in the denominator. So 15 t's will cancel with 15 of the 18, leaving 3 behind. So I have 1 t to the 3rd divided by 4, or you could just say t to the 3rd divided by 4. Take a look. How are we going to reduce 54 divided by 18? Well, let's see. Does 18 go into 54 evenly? Let's see. Let's see what 18 times 4 is. Well, 8 times 2 is 16. Double that, and I get 32. 4 times 1 is 4, plus 3 is 7. That's too big. How about 18 times 3? 3 times 8 is 24. Carry the 2. 3 times 1 is 3, plus 2, 54. That worked. So 18 goes into itself once and into 54 3 times. Now we can simplify our k's and our m's. 8 cancels with 8 of the 11, leaving 3 behind, so k to the 3rd. M to the 6th divided by m to the 4th. These 4 cancel with 4 of the 6, leaving 2 behind. So our answer is 3 k to the 3rd m squared. I know I'm not doing the odd ones, but I just want to mention a little hint for number 14. I would recommend moving your negative exponents first. So this one's going to move, and this one's going to move. Simplify across, and then simplify up and down. I will be doing 17, so that'll be a little bit like that. 17 will be a lot like 14. Number 15, says 3x to the negative 8 times y to the negative 11. So here it's important for me to realize that this entire time, really, this is divided by 1. We never actually write in that denominator, but it is always there. It's important for me to see that because this term has a negative exponent, and this term has a negative exponent. Both need to move. 3 is not grouped into either piece with parentheses, so 3 is going to stay. Sorry guys for the marker, but I want to get it skinnier. So I have 3 divided by x to the negative 8 is negative in the numerator. When it moves to the denominator, it becomes positive. Y to the negative 11, that was negative in the numerator. As soon as it moves to the denominator, it's positive. Now I check 3, there's no other number here to simplify with 3 as a fraction out front, and these do not have the same base, so I am all done. (17). So again, if you were a little stuck on 14, 17 is a lot like 14. I look across, there's really no work for me to do. I look across, there's no work. But I do see I have negative exponents that I could move first. So let's do that. X to the negative 5, got to go. W to the negative 10, and Y to the negative 12. Notice I'm not just circling the powers. I saw that a couple times in class today. We don't just circle negative 5 because it's one piece. X to the negative 5. That is one whole piece. So let's get to rearranging. W to the 10th, Y to the 8th stays. Notice they're not circled. Those stay in the numerator. Let's ask ourselves what comes up top. W to the negative 10 comes up top, becomes a positive 10. Y to the negative 12 comes up and becomes a positive 12. All divided by x to the 7th stayed, and then x to the negative 5 comes down where it becomes positive 5. The power becomes positive 5. I have no more negative exponents to worry about, so let's see what we can do. When I look across, w to the 10th and w to the 10th catches my attention. Product of powers, we add the exponents, that becomes w to the 20th. Y to the 8th times y to the 12th, add 12 and 8, we get y to the 20th. All divided by x to the 7th times x to the 5th, same base, add the powers. 7 plus 5 is x to the 12th. Now I look again, w, y, and x, those are all different bases. That's as far as we can go. (19) and 18 are similar, so let's work on 19. In class today, we had a good conversation about how now that we have our toolbox, there are multiple ways to get to the same answer. So here, when I see that I have a power on the outside, technically I could send it in right away. But I do have an option of using all of my properties on the inside first and sending in that -4 last. Let me show you what I mean by that. First, I look at 2/3. 2/3, nothing I can do with that. So the 2 is going to hang out up in the numerator, and 3 is going to hang out in the denominator. Nothing's happening to those values. I see I have negative exponents, so immediately I'm going to move those first. So I circle x to the -5, and I circle x to the -14. So inside parentheses, I now have 2 y to the 12th, x to the 14, divided by 3 y to the 8th, x to the 5th. So all I did there was take care of moving my negative exponents. I see that I can use my quotient property on the y terms and the x terms. So 2. Let's reason this out. There are 12 y's in the numerator, 8 y's in the denominator. So these 8 y's cancel with 8 of the 12, leaving 4 behind. Here, these 5 x's cancel with 5 of the 14, leaving 9. So when we write what's left, we've got 2y to the 4th, x to the 9th, divided by 3, raised to the negative 4th power. Now let's send in. There's nothing else I can do on the inside. Now I'm going to send in the negative 4. So this becomes 2 to the negative 4, y to the negative 16, x to the negative 36, all divided by 3 to the negative 4. So now when I look, I've got negative exponents everywhere. This is going to move, this is going to move, this is going to move, and this is going to move. Everything's moving. So literally the entire numerator is moving to the denominator, and the denominator is moving to the numerator. So that gets me 3 to the 4th divided by 2 to the 4th, y to the 16th, x to the 36. X and y's, those are not the same base. The only other step possible is to figure out what is 3 to the 4th. 3 times 3 times 3 times 3. That's what we're talking about. So 3 times 3 is 9. 3 times 3 is 9. 9 times 9, 81. So to show you what I just did, this is what I was trying to figure out. I could do 3 times 3 is 9, times 3 is 27, but then I get a little stuck when I try to multiply by the final 3. So in my head, instead, I thought 3 times 3 is 9, 3 times 3 is 9, 9 times 9, 81. Nice little mental math right there. 2 to the 4th. Multiplying by 2s, that's a little less difficult for our brains. We're good with 2s. 2 times 2 is 4, times 2 is 8, times 2 is 16. So again, we just did 2 times 2 times 2 times 2. 2 times 2, that's 4, times 2 is 8, times 1 more 2, and we get to 16. The y and x term are staying right where they are. So y to the 16th, x to the 36, and we're done. Number 21 was a favorite for class discussion today because people were trying to do all sorts of craziness. And on the whiteboard, I drew attention to this. And we talked about the zero exponent property. Anything raised to the 0 power, no matter how crazy it looks, equals 1. So there's actually no work at all needed for number 21. So folks, that covers the odds for the entire type 3. I'm hoping this helps you with any of the evens you were stuck with or any of the scavenger hunt questions you maybe needed some help with. So as you're working to clear up any blanks or any questions you have not done up through page 17, please don't hesitate to send a question on Remind. If I see it and I'm still awake, I promise I will answer. Otherwise, stop by first thing in the morning and I'll take a look then. Have a good night, guys. Bye.